Justin Ballmer. I'm the project portfolio manager and I am the hardware engineer for this project.
My name is Shariah Johnson. I am the software engineer for the project.
I'm Jocelyn, Jiao, and I'm the SolidWorks designer.
My name is Alli, Reno, and I'm the team facilitator for the project.
In this project, the team is tasked with creating an AEV, which stands for an Advanced Energy Vehicle. The AEV stems from a railplane form of transportation first created by George Benny in 1921. The railplane car was designed to run on an overhead monorail powered by propellers. Unfortunately, Benny could not receive the financial aid for the project and had to abandon his work. For this project, our team's goal is to design an autonomous AEV that concentrates on efficiency, consistency, and sustainability. The primary objective is to complete one full run around the AEV track. During this run, the vehicle is required to stop at a gate and wait for the sensor's release. It will then approach the cargo and attach itself. It will then traverse back to the gate, wait, and return back to the original drop-off area.
During the design process, the team had to brainstorm possible ideas for the body of the AEV. The team initially came up with 4 individual concepts, one from each team member.
Alli's concept sketch was horizontal with components mounted above and below it. Jocelyn's sketch used wings to mimic an airplane. Justin's design used wings on an angle, which looked like a bird in flight, and Shariah's sketch was vertically oriented. Combining elements of each member's concept, the team created 2 prototypes to test. The first design was based off the F-15 fighter jet, featuring a vertical body and wings on the backside with components mounted to the base. During test runs, the design showed sparse movement and wobbled on the track. After testing, the first concept design was found to be heavy, inconsistent, expensive, and unbalanced. To fix the first design's balance issues, the second design was implemented horizontally with a T-shaped base with components mounted above and below it. To decrease cost and weight, the team replaced battery mounts with zip ties. This resulted in a second AEV that was lighter, less costly, and more balanced. To compare, we tested both vehicles on the track using the same program. The first design needed a greater speed to power it and in turn used more energy than the second design. After testing both vehicles, we determined that the second design was to be the final design due to its consistency, inexpensive cost, and lower energy use.
Once we chose our final design, we needed to determine which individual components would be used. We used the T-shaped base having the Arduino board, electric motors, count sensors, propellers, wheels, L-shaped arm, and zip ties to mount the battery. Our final weight for the vehicle was 229 grams. Overall, our final test was a success. The AEV makes it to the gate and stops for the required amount of time before traveling to pick up the cargo. The AEV then proceeds to move backwards towards the gate, but does not make it fully to the gate on its own. Once moved to the gate manually, the AEV passes through and travels back to the drop-off area without any concerns. The overall energy used by our AEV was 268 joules.
Looking back, we would have liked to improve our energy efficiency slightly more. However, we devoted our time to enhancing our vehicle's code to complete the required project tasks and objectives. To sum up, this project has taught each individual team member valuable engineering concepts, including the design process, gathering wind tunnel research, and valuable making decision techniques. The team was able to get hands-on experience with software programs including MATLAB, Arduino IDE, and SolidWorks. Not only did we learn to provide real-world solutions, but we also enhanced our capabilities to work as a team to meet deadlines.